As we talked about earlier, there is no distributive property in terms of distributing trig functions into parentheses. So for example, if I was dealing before with the sine of 45 plus 45, this was not equal to distributing sine in. We could not say that this is the same thing as the sine of 45 plus the sine of 45. We have to simplify inside parentheses first. So the sine of 45 plus 45 is the sine of 90. And this is really easy to show that this can't be the case because you know that the sine of 45 is square root of 2 over 2. And if you add square root of 2 plus square root of 2, that does not equal 1, because you know the sine of 90 is equal to 1. So these two things aren't equal. So that shows that this distributive property does not work with sines, cosine, tangents, and the other trig functions. So how do we come up with a relationship or a value when we've got two angles in parentheses? And the way we do that is with the sum and difference identities. There are 6 sum or difference identities we want to look at. One is with sine, one is with cosine, and one is with tangent. So first of all, the sums. The sine of a plus b is not the sine of a plus sine of b. You cannot distribute. Rather, it's going to be the sine of a times the cosine of b plus the sine of b times the cosine of a. There's this extra cosine piece in there that we've got to consider. The sine of a minus b looks very similar. Sine of a times the cosine of b, but this time we're subtracting. Sine of b, cosine of a. So with this one, you've got sine and cosines. They're different types of trig functions with each angle. Sines are the same though. When we get to the cosine pieces, all the cosines and all the sines are grouped together. So here, cosine of a plus b is cosine of a cosine of b, but then we have to subtract sine of a sine of b. Notice this is subtraction, but my original equation was plus. Cosine of a minus b then, same idea, cosine of a cosine of b, but this time we're going to add the sine of a and the sine of b. The last one then, tangent of a plus b. We know tangent is sine divided by cosine. So I'm going to take the sine of a plus b and I'm going to divide it by the cosine of a plus b formula. And we come up with tangent of a plus tangent of b over 1 minus tangent of a tangent of b. And then same thing with tangent of a minus b. We're going to take sine of a minus b and divide it by cosine of a minus b, which looks very similar to what we have above, but our signs are just switched. So tangent of a minus the tangent of b all over 1 plus the tangent of a tangent of b. So what we're going to do first is we are going to break down our sum and difference identities into those two separate angles. So if I were to have the cosine of 60, maybe that could be the cosine of 30 plus the cosine of 30. Or if I would have the cosine of 70, maybe that would be the cosine of 40 plus the cosine of 30. So I've got to break down my angle into two separate angles. So that's what we're going to start with here. Using the sum and difference formulas, find the exact value of the sine of 75 degrees. Now, if I plug sine of 75 degrees into my calculator, I can get an answer. So pull out our calculator, sine of 75 degrees, making sure that I'm in degree mode. So sine of 75 is going to be this weird decimal, 0.9659. But however, I want the exact value. So when I'm looking for exact value, I'm going to have square roots in my final answer, or whole numbers. This right here is a rounded answer. So I cannot just plug it into my calculator. I'm actually going to have to come up with an exact value. And the way we do that is with the sum or difference formulas. Now, we're looking at the sign here, the sign of 75. So I'm going to use one of these two equations. And either one's going to work, but one is simpler than the other. And in this case, let's use the sum formula. We know from the unit circle the sine of 30 and the sine of 45. 75 degrees here is the same thing as me saying the sine of 30 plus 45. So I'm going to break down my angle measurement into two values that I know from the unit circle. If I knew, say, 31 and 44, I could use that as well. Or any other two angles that add up to be 75. But since 30 and 45 are on the unit circle, those are the values that I would choose. So here, A is going to be equal to 30, and then B is going to be equal to 45. So what I'm dealing with, the sine of A plus B, and my formula is the sine of A cosine of B plus the sine of B cosine of A. And since I know A is 30 and B is 45, I'm going to substitute in. So the sine of 30 plus 45 is the sine of 30 cosine of 45 plus sine of 45 cosine of 30. And each of these values individually are on the unit circle. Sine of 30 degrees we know is 1/2. Cosine of 45, square root of 2 over 2. Sine of 45, square root of 2 over 2. And cosine of 30 is square root of 3 over 2. So now I can simplify each of these pieces. So square root of 2 over 4 is my first fraction, and then square root of 6 over 4 is my second fraction. So my exact value for the sine of 75 is the square root of 2 plus the square root of 6 over 4. Now let's confirm that. We know right there the sine of 75 is 0.9659258 and so forth. Let's plug in this answer and see if it's the exact same thing. So the square root of 2 plus the square root of 6, and we're going to divide that by 4. And you can see, sure enough, that is the same thing. So the exact value of the sine of 75 is square root of 2 plus square root of 6 all over 4.